Throughout human history, mankind has shared an innate trait. The desire to explore. Prehistoric men and women may have stood curiously at the opening to caves and wondered what was over the next hill. Ancient voyages sail to distant lands, risking hardships and even death in hopes of discovering a new place. The 20th century saw a massive transformation of humanity's exploration, which took the next logical step, venturing into outer space. There is no doubt that space exploration is one of the biggest achievements in human history. Unlike in many science fiction movies and TV shows, the space travel reality is far from the luxury. Spaceships such as the Star Trek franchise's USS Enterprise. Obviously we can't use warp drives or teleporters to zip around the cosmos, and for the near future we are stuck with spaceflight that trundles through the void. For years there have been many theories and ideas for interstellar travel. These include nuclear propulsion, ion drive engines, constant acceleration drive. The list goes on. So right now our rocket ships we're still using just what we call chemical energy, so very little has improved in our capacity to propel ourselves through space. Since for 100 years almost now, so there's been some talk about other kinds of drives. One of them is a solar sail, where you can use propulsion from sunlight that you open up a huge sail relative to the size of your craft so that you get maximum sort of pressure from sunlight, and that can accelerate you for free. And with the way you'd move around is you would attack just the way you would a sailboat. You would tack into the wind or away from the wind, but here the wind is sunlight that you're doing this with, and then you can navigate the solar system. It's a little slower, but maybe you would ship cargo that way and then send people faster. And so the future of space exploration need not be limited to chemical energy. There are other drives. There's a plasma drive, where you have very hot gas and you let very high-speed particles come out, because the hotter gases, the faster the particles move, and you let them come out, and that is a very low impulse propulsion. No, you're not going to sort of accelerate very much when one particle comes out, but this accumulates and you can ultimately accelerate to very high speeds doing so. Now, so here's the problem with this and all these frontier means of propulsion. Yeah, you can go real fast with them. Instead of taking 9 months to get to Mars, you'll take a month. Perhaps if you want to go to visit Saturn, instead of taking 20 years, you'll take 2 years. But even if you got to the speed of light, near the speed of light, because you're not going to reach the speed of light near the speed of light you want to cross the galaxy, we'll watch you do this. By our time reckon, it'll take you 100,000 years. At the speed of light, by the way, you will age much more slowly, so you'll get there without much time having elapsed, but we who sent you will see you take 100,000 of our years to do that, and so this is not a realist. You come back, we would have all long forgotten about you. That's if civilization is still here. So none of these drives solve the interstellar travel problem relative to a human lifespan. If we lived a million years as individuals, sure, who cares if it takes 1,000 years to get somewhere? That's 1/1000th of your life. Sure, if it's a really interesting place worth going to, so what we really need is wormholes. Just you open a door here, and on the other side of the door, on the back side, you're in another part of the galaxy. Current technologies cannot grasp these ideas, and space travel will remain something that involves very long and exhausting journeys for the near future. Despite this, we as a species are driven to explore the unknown, discover new worlds, push the boundaries of our scientific and technical limits, and then push further the time in a close quarters with only 1 or 2 or 3 other people. Months and months, and in some cases years. There's a whole psychological dimension to that. Can we remain emotionally stable over those times on Earth? People kill one another, they get into fights, there are many even in the film Interstellar. There's an astronaut fight scene, so there's the fact that if you fly without creating artificial gravity, that you are weightless the whole time. Are you perpetually motion sick, or do you get used to it? And if you get used to it, are there any other factors on the body? Your body expects 1 gravity, 1 we call it, which is the equivalent of Earth's surface gravity through space. If you can create artificial gravity, good. If you can't, what is it like to be weightless for a year en route to your destination, or longer? We already know some of the answers to that. You begin to lose bone density. Other things, they worry about food. Not only is there enough food, but will you like the food? If you get bored with the food, will that affect your morale, and then you're less effective doing other tasks? Do you need comfort food? Do you want exotic food, international food? Is there enough water? Do you recycle the water? If you recycle the water, that means it collects all of your urine, filters it, and then you drink it back. Is that too freaky for you to do? Little things that we take for granted are not something that is normal when you are in space. There is a strong fundamental interest in going back and studying the moon, as well as exploring its minerals, water, and energy resources. The moon and Mars can be viewed as stepping stones on the way to becoming a spacefaring civilization able to thrive beyond Earth's orbit. Mars has a lot to offer. It is not only a fascinating place in its own right, but it will also become the stepping stone towards further exploration of our solar system. Curiosity and explanation are vital to the human spirit, and Accepting the challenge of going deeper into space is the next natural step in human evolution. More than 50 years after the astronauts of Apollo 11 made their historic voyage to the moon, it is time to feed that spirit in a new generation and inspire the next great young scientists to follow in their footsteps. The red planet is ideal for human colonization and has been named as the most viable option for permanent colonization in our solar system, but the many aspects of human space exploration are inherently interrelated and go beyond simply launching spacecraft into orbit or landing astronauts on another planet. A large proportion of current research into space is involved in understanding how to keep humans alive. When a spacecraft built for humans ventures into deep space, it requires an array of features to keep it and the crew inside safe. Both distance and duration demand that spacecraft must have systems that can reliably operate far from home, be capable of keeping astronauts alive in case of emergencies, and still be light enough that a rocket can launch it. So if we want to send a spacecraft all the way to Mars, first we will need a fast rocket to escape the pull of Earth's gravity. The heavier the spacecraft, the more powerful the rocket needs to be to lift off. You have to leave when Mars and Earth are properly aligned. So just to remind people, if you see Mars in the sky and you start traveling to it, you have to travel to where Mars will be when you get there. So it's a matching of trajectories that matters here, and so what we call the minimum energy trajectory. So it's one where you burn your engines and then you shut them off, then you coast to Mars until Mars pulls you into its gravitational influence, and then you fall towards Mars. That takes about 9 months, but if you run your engines the whole time, which we can't do yet because we don't know how, because we don't have enough fuel. If we have filling stations along the way, you could do this. You fill up, burn your engines, and then you're accelerating to Mars. By the way, that will give you gravity, artificial gravity inside the ship if the ship is accelerating, and then, but to slow down you have to turn the ship around and then accelerate to slow down. And but anyway, if you do that, you get to Mars in weeks, a few weeks, but it'll take a boatload of fuel to do that. But if fuel is cheap, then why not just need filling stations? According to NASA, a one-way trip to Mars would take about 9 months if you wanted to make it a round trip. All in all, it would take about 21 months, as you'll need to wait about 3 months on Mars to make sure Earth and Mars are in a suitable location to make the trip back home. Through addressing the challenges related to human space exploration, we expand technology, create jobs, and encourage innovation. We are inspired by the successes of our technological processes on Earth and beyond. The knowledge we gain will have a transformative effect on life on Earth and help us to strengthen our economy, all while furthering space exploration and the desire to understand our place in the universe. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this. Music you.